Okay, this is Giancoli AP Edition, 7th edition. We're in Chapter 10, Fluids. We'll be working on Problem 1 today. The problem reads, the approximate volume of the granite monolith known as El Capitan in Yosemite National Park, figure 1047 shown below, is about 10 to the 8th cubic meters. What is its approximate mass? So as with most of these problems, we're going to start by identifying the quantities we have available. Now they tell us this is the volume, and it makes sense dimensionally. That is a cubic length, cubic meters in this case. So that is our volume. And they're asking us for the mass. One of the earlier topics in this chapter is the concept of density. That equation is given as density is mass per unit volume. That is the definition of density. Now, since they're asking us for mass and they've given us volume, it seems like a glaring omission here that we're missing the density. But if you read the problem carefully, it does tell us that we are working with granite. If you flip back to an earlier page in the chapter, this is table 10.1, very early in the chapter. We can look up the densities of various subjects. If you recall, the density is a function of the material. It has to do with the molecular density of the atoms. The vast majority of the mass, as you may know, is contained within the nucleus of each atom, and most of atoms are empty space. So the combination of those two values will tell you the density of the particular material. In the case of granite, that density is indicated right here. 2.7 times 10 to the third. As always, we got to be careful of our units to make sure they're compatible or convert them. In this table, the units are given in kilograms per cubic meter. So we have our values now. As we always do, once you have an equation that has everything you need, rearrange that equation until the thing you want equals stuff you know. In this case, we're looking for mass, so we're just going to cross multiply the volume across, flop the equation around, and you get mass as density times volume. Now we have the thing we want equals stuff we know. We're ready to plug in our numbers and look for unit conversions. Our density is 2.7 times 10 to the third kilograms per cubic meter. Move that table out of the way for now. Substitute in our volume. Given in the problem is 10 to the 8th cubic meters. And now you're ready to pick up your calculators and calculate, confirming that the cubic meters in this case will cancel, leaving you with kilograms, which is a mass, and that's what we're looking for. After entering that in your calculator, or because we're dealing with just times 10 quantities here, we can easily determine that that is 2.7 times 10 to the 11th kilograms. We've answered our question. On to the next.